Today we are going to start the 10th chapter. The name of the 10th chapter is called Oscillations. Here in the beginning of the chapter Oscillation, we are going to learn the term called simple harmonic motion. Already you may have learnt about different kind of motions in the previous topics. Linear motion, circular motion, rotational motion. So different kind of motions basically they were already taught in the previous classes. Now you are going to learn a new term called simple harmonic motion. It can be simply called as SHM. In future, instead of saying simple harmonic motion, we can call it as SHM. Here, to explain the concept of simple harmonic motion, I have taken the pendulum, simple pendulum. The oscillations of the simple pendulum is the best example for simple harmonic motion. Now I am going to oscillate the pendulum. You just observe the movement of the pendulum. Here the pendulum it is at rest. I have drawn a line along the length of the thread. The name of the position is called equilibrium position. The name of the position is called equilibrium position. Now I am going to displace the bob, that is pendulum, from the equilibrium position. After displacement, what happens? Look at that movement. Look at the movement of the pendulum. It is oscillating here and there. With respect to that equilibrium position, that bob, that pendulum, it goes to the right extreme end. Again it crosses the equilibrium position. Again it goes to the left extreme position. Again it crosses the mean position. Again it goes to the right extreme. So with respect to the mean position, the pendulum it oscillates. This kind of motion is called a simple harmonic motion. Each time the oscillating particle that has to go across the equilibrium position. Are you clear? Only then the name of the motion is called simple harmonic motion. Now this is not sufficient to explain the simple harmonic motion. Now look at that. Now I am going to measure the displacement. Now you are going to learn what is displacement. Now I am going to move the pendulum from the equilibrium position to some other position. So I am keeping here. Now this is called displacement. Are you clear? Let us take it as x-axis. Are you clear? Now this distance is called displacement. From the mean position up to the position of the pendulum, the in between distance is called, what is this? Displacement. So x is nothing but displacement. Are you clear? Now x, that one represents the displacement of the oscillating particle. So this is displacement. As soon as it is displaced, what will happen now? Now I am leaving the pendulum. Just observe in which direction it moves. Again it goes towards the mean position. It goes towards the equilibrium position. So which one makes the particle to go towards the mean position? There acceleration is acting on the particle, acceleration is acting on the bob. That one is always acting towards the which one? Mean position. Therefore in this direction which one acts? Acceleration acts. Are you clear? If it is displaced, acceleration will bring back the bob to the mean position. Are you clear? If it is further displaced, what happens? Look at that. Now the displacement is increased. Further the displacement is increased. Now acceleration also increases. Are you clear? If the pendulum is further displaced to the greater extent, now the displacement is increased to the greater extent, proportionately the acceleration will also increase. Are you clear? Proportionately, which one will increases? Acceleration acting on the particle also increases. So acceleration that takes place in this direction, displacement is taking place in this direction, acceleration is taking place in this direction. Always the displacement and acceleration, both of them will be acting in the opposite direction. Both are vectors. Again I will explain. These are all displacement. x1 means the acceleration acting on the particle can be taken as a1. If it is x2 means acceleration acting on the particle can be taken as a1. If it is x3 means the displacement acting on the particle can be taken as a3. Are you clear? So when displacement increases, acceleration also increases. Are you clear? Now Which two are directly proportional? Acceleration is directly proportional to which one? Displacement. Can you understand my point? Now I am going to displace the bob in this direction. Look at that. So the bob is displaced in this direction. This is the direction of the which one? Displacement. Now in which direction that acceleration will be acting? Acceleration will be acting in this direction. Are you clear? That acceleration, it tries to bring the bob towards the mean position, that is towards the equilibrium position. If it is further displaced, acceleration increases. Displacement also increases. When the acceleration is more, means it shows that the displacement is also more. Clear? When a displacement is more, because of that the acceleration also becomes more. Both are directly proportional to each other, but they are acting in the opposite direction. If it is further displaced, what happens? The displacement is still greater, acceleration also becomes greater, but it is acting in the opposite direction. Understood? The point is, the main important thing is both acceleration and displacement both are directly proportional to each other, but they are acting in the opposite direction. Now look at that. Here, clear, when it moves in this direction, displacement increases. Acceleration is acting in this direction, acceleration also increases. So each time it crosses the equilibrium position only because of the acceleration. Are you clear? So always acceleration will be acting towards the equilibrium position, that you should not forget. In simple harmonic motion, acceleration will be always acting towards the equilibrium position. When it goes to that side, acceleration will be acting in this direction. When it comes in this direction, acceleration will be acting in this direction. Okay, look at that. Now I am displacing the bob. Now displacement is more. Acceleration is acting in this direction. In the bob it goes here, there the displacement is more. Okay, acceleration will be acting in this direction. Each time that acceleration brings back the bob to the mean position. Are you clear? So each and every time, clear, what happens? That acceleration, it tries to bring back the bob to the mean position. So which two are directly proportional? A, that is acceleration acting on the particle, is directly proportional to displacement x. So the next equation, A should be equal to minus of a constant must be introduced, that is called B and x. Why negative sign is there? That negative sign that indicates that, it's clear, A and x both are acting in the opposite direction. Here I have introduced a constant. The name of the constant is called, what is this? B. What is B here? B is nothing but A divided by x. Are you clear? Acceleration per unit displacement. What is this? B is nothing but constant. How to calculate B? How to calculate this constant B? Acceleration per displacement, per unit displacement is called B constant. Are you clear? Now we are able to get the unit for this. Are you clear? So this is measured in terms of meter per second. Are you clear? This is measured meter per second square. This is measured in terms of meter. Are you clear? So what will happen finally? Meter per second square into 1 by meter. Are you clear? Both of them can be cancelled. So second power of minus 2. Second power of minus 2 is the unit of which one? The constant B. Any doubt on this? So this is the very important equation. This is called as the equation of simple harmonic motion. This equation can be called as, what is this? Equation of simple harmonic motion. Here, since that acceleration is acting on the mass, now we can convert this A is equal to minus Bx into force form. Are you clear? So we know Newton's second law. Are you clear? So here, what is the formula to calculate the force? F is equal to m into A. Are you clear? By multiplying the acceleration with the mass, we are able to calculate the force acting on the body. Here that, what is that? Bob, it possesses mass. On the bob, acceleration is acting. Therefore, we are able to get the force. Are you clear? Let us take the equation. A is equal to minus Bx. Are you clear? On either side, clear, multiply by m. M into A is equal to minus B m into x can be written. Are you clear? Now this m into A can be replaced by the factor called force. F is equal to, here m is a constant, mass of the body is constant. B, already it is a constant. This B and m both can be combined and it can be written in terms of a common constant called, what is this, K. Are you clear? This can be, both of them can be combined and it can be written as K, K into x. Now this force must be called as restoring force. Are you clear? Because here when the bob is released, when the bob is moved, what happens? Displacement occurs. From here to there you have to calculate the displacement. Now the acceleration is acting in this direction. Therefore restoring force also acting in the same direction. Are you clear? Look at that. Acceleration is acting in this direction means restoring force also acting along the direction of acceleration. Why it is called restoring force? Because this force, it acts on the bob, it tries to bring back the bob to the original position. That's why restoring force will be acting in this direction. When it comes here, restoring force will be acting in this direction. When it goes there, restoring force will be acting in the, as a clear, opposite direction of the displacement. Are you clear? Look at the direction of the restoring force. Restoring force and acceleration both are acting in the same direction, that is towards the equilibrium position. Are you clear? When the bob is displaced, displacement happens in this direction, both acceleration and restoring force will be acting towards the equilibrium position. When the bob goes there, what will happen? Here, that is the direction of the displacement, both acceleration and restoring force will be acting towards the equilibrium position. Are you clear? So that's why that force is called restoring force. Always don't forget, these are all the terms will be often used in the lesson. This force must be called as, what is this? Restoring force. Are you clear? What is this? Restoring. Because the force acts on the mass that tries to restore back the bob towards the equilibrium position. That's why this is called as restoring force. Are you clear? Now we are able to name the constant. Are you clear? Now we are going to say what is K. K is called force constant. What is this? K is called force constant. How to get the value of force constant? K is equal to, small k is equal to F divided by x. This is a very important formula throughout the lesson. Wherever k comes, you have to call it as force constant. What is force constant? Force per unit displacement. Restoring force per unit displacement is called force constant. So what should be the unit of force constant? Here F, that is measured in terms of Newton, and displacement is measured in terms of meter. Therefore Newton meter inverse, what is this? Newton meter inverse is the unit of, what is this? Force constant. Are you clear? I will write it here. Newton meter inverse is the unit of whom? Force constant. Make a note. Are you clear? So we have learned two constant. One is called B. What is B here? This is called as A by x, acceleration per unit displacement. Its unit is second power of minus 2. Here from this formula, which formula? F is equal to minus kx. So clear, we have got the unit of force constant. Its unit is Newton meter inverse. So here you are not supposed to forget two equation, that A is equal to minus bx and F is equal to minus kx. These two equations are very important for further learning about simple harmonic motion. Don't forget, these are the two basic equations that should be often used in the lesson for various derivations. Don't forget. Force constant also important. This one will be often asked in the 2 mark also. How to define force constant? Force, restoring force per unit displacement is called, what is this? Force constant. Its unit is Newton meter inverse. Are you clear? So if any movement, look at that, if any motion, if it obeys, if the motion obeys either this equation or this equation, only then the motion is said to be simple harmonic motion. Again I will repeat, clear, if any motion or movement, when they obey either this equation or this equation, then the type of motion is said to be simple harmonic motion. Understood? Otherwise they never be called as simple harmonic motion. And in the meantime, they have to go across the mean position. Or you clear, each and every time it has to go across the mean position. If they go to the left extreme end, again they have to come back towards the nuclear equilibrium position. Again it has to go across the equilibrium position. Again it has to go to the right extreme. So each and every time it crosses the which one? That mean position. Such kind of movement is called, what is this? What is this? Simple harmonic motion. So the motion of the pendulum is the best example for which one? Simple harmonic motion. Understood?